mechanisms. And they deal with concentration. Sometimes when we increase concentration, we find that it speeds up a reaction. Other times, you add other things and it doesn't. Until about 30 years ago, it was not understood why. If you increased the concentration of one of the things that you were using, it just didn't increase the whole reaction. We now understand that a reaction with 4 or 5 atoms doesn't just happen all at once. If you are trying to manufacture something that has 5 or 6 or 7 atoms in, those atoms just don't meet in the corner of your beaker at the same point in time and bond together. They hit each other. There's just 2 things that hit each other per unit time. So those molecules form in a series of steps, and the steps are called the mechanism. So we see most collisions only involve 2 particles, and the reaction proceeds in a series of steps. So we have step 1. A and B hit each other, and they form an intermediate product called AB. Intermediate products don't exist at the beginning, and they don't exist at the end. They only exist for a brief period of time, and then they disappear. They're consumed. Then step 2, you got your intermediate product, your little AB, hit by another A, and now you get your final product, which is made of a B with 2 A's. It's made of 3 atoms, but all 3 atoms didn't meet at the same place. It was formed in a series of 2 steps. AB hit first, and then A hit them. The propensity for 3 or 4 things to all hit at exactly the same time is low. We then make what we call a net equation. We have 2 A's involved, and we have an intermediate product, and B. And then formed, we have an intermediate product, and C. If we cancel both intermediate products, which really did exist, but for a limited period of time.
It was inside the toilet.
Not like that.
It was like floating.
I
was kidding.
Seriously.
Okay.
So
We have then
It was
what we call the net equation, which is 2 A's plus a B yields C. Now they still didn't understand why you could add some things and that would increase the rate and other things and it wouldn't. Until we knew that there were a series of steps, and it was only one of the steps that was slow. The slow step in a chemical reaction is called the rate determining step. You have to speed up the slow steps in order to increase the rate of a reaction. If you add chemicals that are involved in the other steps that are already going as fast as they can, you're not going to increase the rate of the reaction. You have to add chemicals involved in the slow step. This is like, say, you're sending out a bunch of flyers, and you got one room of people and they're typing up the flyers, and the next room of people are folding the flyers, and the next room of people are putting them in envelopes, and the last room of people is supposed to be addressing the envelopes. And you're waiting to mail them, and you're getting nothing. So you start walking from room to room, and the people are typing really fast, and other people are folding, and other people are putting them in the envelopes. And you go to the last room where they're supposed to be addressing them, and nobody's doing anything. Are you going to go yell at the people in the first 3 rooms? No. You're going to address the slow step. The only way you're going to increase the rate of the whole thing is to address the step that's holding everything up. That's called the rate determining step. In chemistry,